Hello guys, you're welcome to the 16th video in this series. So in the last video we were talking about conversions, and we talked about converting between custom types. We talked about the from and into traits, and we talked about the try from and trying to trade for fallible types, which means types that you could possibly not convert for various reasons. So in this video I want to talk about converting to and from strings, right? So how exactly is that going to work? Well, so say we have this simple struct where we have my struct with a name having a string, right, and possibly age having an I32. I mean U32 is probably more appropriate, so I'm going to use that instead. So I want to implement two strings. So I want to be able to call this function. What the hell? Print line to string. I mean my struct. And then have this become so let me my struct where we're gonna have name is gonna be string from, and then I'm gonna have my age become something like 10. Of course I'm not 10 years old, but hey, it doesn't matter, right? So I want to just be able to do me or me.toString, and this should actually work. So how do I do that? I know that there are multiple ways to do this, alright? And this should definitely be an error. Right, so this says that what the hell was it? Right, so it says that the method to string exists for struct my struct, but its trait bounds were not satisfied. Alright, so it says the following trait bounds were not satisfied. So my struct has to implement std format display. Okay, so we have to implement display in order to be able to get the toString. So in order to do this, we have to implement std format display for my struct. Pretty simple, pretty understandable. We gotta implement the missing member, so we're gonna do that right now. Beautiful. So how do we do this? We use what is called the write macro, passing in the formatter and then the format string. All right, so what do we want to do with this? We want to do we want to print out the name and then the age, right? So this is going to give us name and age just like that. And now, oh damn it, self the name and of course self the age, just like that. Now this is going to work, and we can print this out. We can totally print this out. You can see we don't have any errors. And if I run this, you're gonna see that my struct prints added by a 10. Now one other thing I want you to notice in this is that if I remove the toString, we shouldn't get any error message. So remember, since we've started this video, when I wanted to print something out with formatting like this, we usually get errors, so we have to implement debug. But if we implement display, what happens is that we automatically are allowed to use something like this. So which means that age or U32 must have implemented display for us to be able to do this, and same for string, which is our name here. And we can do the same here, and if we run the program, it's still going to work and nothing's going to change because we've implemented std format display, and now we can use toString. Now let's also take another example, because I want to show you guys how do you convert from an integer to a string. Take from a string to an integer, for example. All right, now let me show you what I'm talking about here. No, actually I need this struct just to illustrate a point. All right, so let's say I have my int, all right, I32. So I want to say something like 10 parse what is this, I30, I'm just gonna say parse, right? Let me see, what do I have here? No. It's supposed to be dot parse, right? Right. I don't need this. I don't think I do. Yeah. So, right. So when you parse, you get a result, and then you can unwrap it to convert it to a string, an integer, just as you would expect to get it. So I can print out my int here, and you see that this has been converted to an integer. So if we run this, you can see that we get 10 out there. It's not my struct, but I'm gonna leave that there because I want to illustrate something. But if I change this to some value, just to show you that this actually works, we should panic instead. All right, so this should be panic. You see panicked at unwrap error value, pass int error, invalid what digit. So that's exactly how the parse works. But how is this implemented? So how can we do the same for our struct? So let's say that we have some sort of string. So let's say we have like a string from. So let's say based on our format string here, let's say we have a name. All right. So I can say Adebayo, and then we have this arrow, and then we have a number. All right, so the number is going to be like, let's say just 30. All right, I'm not 30 years. All right, but I'm just going to put any age I feel like. I don't want to disclose my age to you guys. Why the hell do you want to know? Anyway, so let's say we have this value. Now I want to parse this value to give us my struct. How do we do that? It's pretty simple. All we just have to do is implement from string for my struct. So what am I saying here? I want to implement from string for my struct. Now if I want to get an error, I'm going to prefer to just get an error back as a string. All right, so what am I doing here? All right, so when I get a string, what do I want to do? So this is from string. I want to return self. So what I like to do here is that, given that we're going to have 3 tokens right here, right? So what we can do is to say tokens equals to s.split. So what do we want to what kind of pattern do we want to split here? Get out of my face. The pattern we want to split is space. We want to split. So we want to split white spaces because we're gonna get this and this. So we're also gonna do something. So we're gonna assert that we're gonna do assert eq that the what do I get here? Token at 1, all right, equals to yeah, tokens at 1 is actually this. All right, I guess that makes a lot of sense. I guess what I could do first is to trim this to make sure that there is no white spaces from the start and end. And then what is this? Okay, what do we have here? I get a collected really vec of whatever you want to give me. So it's a vec of string, of course, vec of stir or string, whatever you want to call it. Anyway, so we want to assert that whatever is in the middle of this, so we require the syntax be like this. We could have a number of spaces at the beginning and at the end, it doesn't really matter because we're going to trim them out anyway. What we want is a name followed by a space, followed by this token, followed by a space, and then the number we want to get out. All right, so we want to assert that we can do that. Now another thing we also want to do, or we could just say, okay, we don't want to crash, we don't want to panic here, so we're going to say that if tokens at 1 equals to this, right? So if this equals to this, I want to return, actually I'm just going to do the error checking here. So if it doesn't equal to this, we want to return string from expected. So I'm just going to be like expected token here. So I'm just going to do that, right? And then so we should have returned that error here, but we gotta wrap it in an error thing, because it's a result. So we can continue because we now know that the first token is going to be this. So that name is going to be tokens at 0, just like that. And then the last thing is going to be let age, which is a u32, is going to be just say if let age okay, age which is a u32 equal to tokens are 2 the parse. So what I want to parse it as, yeah, I already did that. I guess that's pretty much it. Yep. What is this? expected comma. Alright, I guess this cannot happen, so I'm gonna have to use parse here as a U32. Alright, yeah, that looks like it's making a lot of sense. I gotta take this off though. Yeah. Alright, so if I can parse this, what do I want to do with it? I want to return OK self and name age. Right. And else, so if for some reason we don't have this, then what I want to return name. Okay, I think I have to do it to string. Name is a string, right? I guess. What is this? Expected one of comma whatever. Name age self. Missing structure fields. Alright, there's one more parenthesis. No, not parenthesis. What the hell is going on here? Okay, there's something going on here. Missing structure fields name. Are you serious? Yeah, we're missing name because this is not. Yeah. Anyway, alright. So the next thing we have to do is to just return an error saying, you know, invalid tokens found or children parse input, something like this. Alright. And so after implementing this, what can we do with this? So we want to do something like we have this value for a string, and now I want to get my struct out of it. So what I like to do is to say value dot so my struct equals to value dot parse. I want to parse it as what? Oh, get out of my face. So I want to parse it as my struct. And so the idea is that I should get my struct right back out. I'm gonna unwrap this because I don't want to do any error checking, and now I'm gonna have to print my struct here to make sure that we get the right results. Alright, so let's try this and we run, and now we should get my struct Adebayo 30. And just to make sure that everything works as expected, we could change this to something like Jane, and yeah, that should be it. So you notice that there's actually an error. Alright, I'm gonna get to that in a minute. So Jane is 30, and you can see everything still works as expected. Doesn't matter what number you change it to, it's still gonna work. So you can see just like that. But there's an issue where if I do something like Jane Doe, you know, this is not gonna give you the results you might expect. And why is that? The reason is because you can see it panic saying that expected token this, and we could fix that really pretty easily. To fix this, we're not going to check for token 1 anymore. All we're just going to do is we're going to take this, and we're going to split it using this token right here. Now if we split it with this token, we should be having only 2, so we could say something like if tokens.1 is, you know, does not equal to 2, then we're going to say that return. Okay, wait, we could have like spaces, right? I mean, we split, then what do we have? So we split, I mean, we trimmed all of this, so we should only have this. Okay, but we're still gonna have this, right? No, actually we should have just this and this. Yeah, that's what we should have. So we should only have 2. All right, so if tokens.len does not equal to 2, return error saying that what the hell did you enter? If I can type. Right, so that's how we want to do it. Now if you run the program, no, okay, this is a string, so we get a right string from, and then run the program so we can see the results. And what do we get? We get an error. Len is 2, yeah, so we gotta fix this. This is 0 and this is 1. But before we parse this, we have to trim this because we're probably gonna have like some white space lurking somewhere, so we're probably gonna need to trim this too. And now, get out of my face. So running the program again, we should get the proper results again. Now we can see that our name can now contain proper spaces, Jane Doe and 129. So if I want to write my real name, no, what is this? I'm probably gonna even write like my other name. I'm gonna put like 25 or whatever. That's not really my age, you know. I already promised I wasn't gonna share my age with you guys, so you can see that it doesn't really matter. Now we get the proper age and we get the proper name. All right, and so that will be all for this video. Thank you guys for watching. If you like this video, please leave a like, turn on the notification, subscribe, and thank you guys for watching. I'll see you guys in the next one.